Hello, I am Miguel, presenting BiniX2 again. I'm not going to re-explain the game. All I have to do is re-explain the new method I'm using. So, I'm using PPO, which is Proximal Policy Optimization. Sorry for the flashing lights. We're just going to look at this. This is what the thing sees, kind of. So PPO is a reinforcement learning method which uses a deep neural network. I'm using a pretty simple architecture with 2 hidden nodes. So if you look at this, it's 7 by 5. So the first, the input layer is 35 long. The hidden layers are 64, then 128. And then the output layer just decides up, down, left, and right. And then, yeah. So the way that PPO works, to be different than most other reinforcement learning algorithms, is that PPO has two neural networks which are being trained, an actor and a critic. And the basic idea is that the actor makes the actions and then the critic judges. They're the same exact architecture, but the purpose of the critic is to allow the actor to make steps which are big, but not too big as to possibly fail at gradient descent. You know, you want there, if you have like some hypothetical reward function, you want to find the maximum value that, like, not loss, but a reward value. You want to find the maximum reward you can get without accidentally missing it by like overstepping into another lower value. So yeah, that's the basic idea behind PPO. And as you can see, it's not doing so well right now. It just gets 10 or so, but we're gonna check in around, if we look at this, I expect it to get pretty good around 4,000, which is, I guess, what we'll check back in. And then it reaches its approximate maximum reward around 10,000 times steps, and then it kind of stagnates. Yeah, that's the expected average reward, so I'll check back around 4,000. Okay, so now we're around 4,000, and it's doing a little better. You saw it got to 100 score. I didn't mention initially, I guess I implied it, that the actual reward for the machine learning, the PPO, is just this actual score here. It goes up by 10 every time the player makes a match, and even more if they get lucky enough to combo. As you can see, it's quite a bit better. It can climb up really high sometimes. It gets much higher than it does before, and around 60 almost every time. Way better than the epilepsy hazard that was happening at the beginning. Also, if you wanted to clarification that I hinted to at the beginning, that I'll make explicit here. This isn't literally what the PPO is seeing. Obviously, neural networks, unless you're using a convolutional layer, always take a one-dimensional matrix. This is just for me to have it easier to read. The player is 255, and then every other combination of colors has its own unique number, and then open spaces are 0. And this number denotes which way it's going. So 0, 1, 2, 3, and then 4, 5, 5, that's just the button presses it mashes to reset the scene. So we'll check back in around 10,000 steps. Yeah, for its last performance. All right, so we just passed the 10,000 step mark, and as you can see, its performance, it's sometimes a little swingy, but you can pretty much notice that it is surviving quite a bit longer. It's making it to a higher score more often. Rather than just 60, it's getting to 90 or 100 something more often. And if we look at the logs, the average reward went up quite a bit. If I let it train for like 20,000 or more, it'll get a little better. Oh, that was a really high score. If I let it train for way longer, it'll get a little bit better, but there is a limit.